When you look at a molecule, you can kind of predict its behavior by looking at individual parts of that molecule and the functional groups that are in those parts. So, here are a few functional groups that you need to know. First functional group is that of an alcohol. An alcohol consists of a carbon attached to an OH group. Now, this carbon has to be an sp3 carbon. If it's not an sp3 carbon, then it is not an alcohol functional group. It's a different functional group, such as this. If it's an alkene, then it is an enol. If it is a benzene ring, then it is a phenol. Each of these has a carbon OH moiety to them, but they all behave differently. This is due to the presence of the sp3 carbon and due to resonance. So, alcohol, sp3 carbon, OH. Very similar to the alcohol, there is the amine, which has the general formula RNRR. In this case, R can be an sp3 carbon or a hydrogen. So ammonia, NH3, is an amine. Here we have trimethylamine. Here we have benzylamine. Sorry, that should be an NH2. All of them are nitrogens bonded to only sp3 carbons or hydrogen. They're characterized by the lone pair also being in an sp3 orbital. Okay. If they're attached to an sp2 carbon, then that drastically changes the character of that, and they are no longer an amine. If they are attached to a benzene ring, for example, this is referred to as an aniline. If it's attached to an alkene, this is referred to as an enamine. Again, these are different from amines. Okay, moving on to other oxygen-containing functional groups, we have ethers. An ether has a general formula ROR. Now, R can basically be almost any carbon. So this is considered to be an ether. This is an ether. You can either have ether as part of a ring, like so. You have to be careful. There is one stipulation, that this R group cannot be a carbonyl. If it's a carbonyl group, like so, then it's no longer an ether. Instead, it's referred to as an ester. Esters behave quite a bit differently chemically than ethers do, so they are a different functional group. So here we have an ester. Esters can be part of a cycle, like so. And here's another ester. This is it's called a phenolic ester, but all of these are esters. So we have ethers, esters, amines, and alcohols. Okay. While we're looking at these carbonyls, we have this pattern where R is a carbon or hydrogen, you have an amide. So this is an example of an amide. It consists of a nitrogen directly attached to a carbonyl. It's an amide. Can have amides as part of rings, and so on. Here is another example of an amide. Okay. So, important thing about an amide is carbonyl attached to a nitrogen. On the other side of that carbonyl has to be either a hydrogen or a carbon. So let's clear some space. And let's look at some other functional groups. Okay. Other functional groups involve carbonyl functional groups, such as ketones. Now with a ketone, you have a carbonyl flanked by two carbons. R has to be any type of carbon. So here we have acetone. It's found in nail polish removers. We have methyl ethyl ketone. We can have methyl vinyl ketone. Ketones can be part of a ring. Here we have cyclohexanone. So here are the different types of ketones. If one of the groups attached to a carbonyl is a hydrogen and the other one's a carbon, you have an aldehyde. So things like here we have benzaldehyde. It smells like maraschino cherries or almonds. We have acetaldehyde, which is a molecule responsible for hangovers. Another molecule that's actually an aldehyde, but it has two hydrogens attached to the carbonyl. This is formaldehyde. And for a lot of you in going on to med school, you'll have to get used to the smell of this because it's used as a preservative. So yeah, formaldehyde, aldehyde. So we have aldehydes and ketones. Some molecules have different functional groups attached to them. So this molecule has a benzene ring. It actually has three functional groups. It consists of an aldehyde, consists of an ether, and it consists of a phenol. So it has these three components on this, and together they make up the molecule called vanillin, and this smells like vanilla. Other functional groups, before I forget, here we have a nitrile. It consists of a carbon triple bond to a nitrogen attached to another carbon. So things like this molecule, where it's a methyl group attached to a C triple bond N, is acetonitrile. It's a common solvent. We have another example of a nitrile. This is bonded to an sp2 carbon. Here we have benzonitrile here. All of these are example of nitriles.